Right, hello everyone. We have a question on the board today. 2 raised to power x plus x is equal to 5. And we're asked to find for the value of x. Let's solve this together. So we'll start by moving this x over to this side. So we have 2 raised to power x is equal to 5 minus x. Now we can divide both sides by 2 raised to power x, and this cancels out. So now we have that 5 minus x over 2 raised to power x is equal to 1. If this comes up here, it becomes 2 raised to power minus x equals 1. Right, so now this is what we have here. 5 minus x, 2 raised to power minus x equals 1. Now, for us to carry on here to solve for the value of x, we need to employ the Lambert's rule. The Lambert's rule states that w a e raised to power a is equal to a. So now we need to try to rewrite this left-hand side in this format, in the format of a e raised to power a. So let's try. So here we have 5 minus x, we have 2, and we have minus x. So we have like 5 missing at the top. So what can we do to get 5 up there at the power? So we can multiply by 2 raised to power 5. And also whatever you do on the left hand side, you need to make sure to do the same on the right hand side. So we also multiply the right hand side by 2 raised to power 5. So now we have 5 minus x, 2 raised to power 5 minus x equals 2 raised to power 5. Now this is looking similar to what we have here, but here we have e and here we have 2. So we have another rule that states that e raised to power ln of x is equal to x. So that means your x can be any number. So if you have e raised to power ln of 2, that would be 2. If you have e raised to power ln of 3, that would be equal to 3. Okay. So now let's replace this 2 with e raised to power ln of 2, which is equal to 2, because 2 is e raised to power ln of 2. So this becomes 5 minus x e raised to power ln of 2, 5 minus x equals 2 raised to power 5. Now we see that this is looking almost like they're almost looking the same, apart from the fact that there is a ln 2 now at the top. So what we need to do is introduce ln 2 here. So multiply left hand side and right hand side by ln 2, so that what we have here and there are the same, which will now satisfy what we have up here. Okay, so if we supply ln 2 to the side, I'm just going to go up here. So now we have 5. So we have 5 minus x e raised to power ln of 2, 5 minus x equals 2 raised to power 5. So now if we multiply both sides by ln 2, we have ln 2 5 minus x e raised to power ln 2 5 minus x, 2 raised to the power 5, ln 2. Right, so this is looking more like a e raised to the power a, because this is our a, this is also our a, and then we have our e. Okay, now if we have the Lambert function of this, that should be equal to the value a, right? So now let's employ the Lambert's rule here, and we have ln 2 5 minus x e raised to the power ln 2 5 minus x equals w 2 raised to the power 5 ln 2. All right, so because we have to do it on both sides. Okay, so now this becomes ln 2 5 minus x equals 2 raised to the power 5 ln 2. 2 raised to the power 5 is the same thing as 32, right? So that's 2 times 2 times 2 into 5 places. Right, so to get the value of x, we need to divide both sides by ln 2. So we have ln 2 5 minus x 2 raised to the power 5 ln 2 divided by ln 2. Okay, that cancels out. We cannot cancel out this ln 2 because this is a function in itself. This is a value, so we can't just cancel this out. So this stays this way. Now to get the value of x, we can move x to this side and bring this whole thing to this side. So when we move this whole thing to this side, it becomes minus w 2 raised to the power 5 ln 2 divided by ln 2. And then x goes over to this side and becomes positive. So now we have that x is equal to 5 minus w 2 raised to the power 5 ln 2 divided by ln 2. This is the value of x. So if you learned something new today, make sure you like this video, subscribe, share this video. Make sure that you share it so that somebody else can learn something new as well. I'll see you on the next one.